All right, that's my cue. Hi, friends. My name is Byron Komanek, owner and manager of Jack Solar Garden and the director of the Colorado Agrivoltaic Learning Center. I want to thank you all for joining us for this webinar about operations and maintenance within agrivoltaic systems. I'll introduce our speakers here shortly, but to start off, we'll just give you a little sense about the Agrivoltaic Learning Center that's based here at Jack Solar Garden, Boulder County, Colorado, just south of Longmont. We are a small nonprofit organization that helps to showcase the coupling of agriculture with solar energy so that we can better educate and inspire our community to improve land stewardship within clean energy systems around our country. And we focus in on solar energy systems as the shade provided by solar panels is so important in dry and arid climates like what we have out here in the West. Just from these two images that you see here, we've had folks working at the solar array at Jack Solar Garden under our panels for some years, growing a wide variety of different types of vegetables, as well as having different types of livestock that have joined us underneath the panels, from the dairy cows you see there to red Angus cattle to sheep, ducks, geese, chickens, and maybe one day we'll have pigs even join us to underneath the panels, as who doesn't enjoy some shade when it's blazing hot outside in the middle of the summertime. So let's see, different ways that we help to there we go. Different ways that we help to showcase agrivoltaics is through events on site, to tours, to a handful of different videos that we have available on our website, coagrivoltaic.org. We've had various workshops for solar developers over the years. A lot of opportunities to come out, learn from us, see what's going on, figure out what has worked for us and what could work for you in your area or your solar array, in terms of incorporating agriculture to even ecosystem services within a solar array. It has been a lot of fun hosting tours over the years. We get between 1,500 to 2,000 people coming out each season here at Jack Solar Garden, creating a variety of different memories, like these two girls here that found a worm as they were digging out raspberry plants from underneath our solar array. There's a lot of opportunity to incorporate not just agriculture, but agritourism within solar arrays, just as another means of generating revenue for a farm, and providing educational opportunities for community members that want to come out and do it. We've hosted a variety of different webinars and seminars over time. Our last webinar back in February showcased some policymakers in our community to talk about how we can engage with policymakers on agrivoltaics. And this evening, we have an in-person seminar at the Dairy Arts Center in Boulder, where speakers from the Colorado Energy Office, our Colorado Ag Commissioner, and the head of the Solar and Storage Association in Colorado will come out and speak about the rollout of solar energy in our state and the future of agriculture. I want it to be agrivoltaics, but we also need to learn more about just agriculture in general, so you know how to do the two together better. So we keep creating more and more opportunities as to how folks can learn from these webinars or in-person seminars, workshops, and so forth. And this is important because policies are changing rapidly at the federal level. They're changing on a regular basis at the state level, and various counties and smaller communities around our country are also changing their viewpoints on solar on farmland. So it's important that we're able to get information out to communities around what it looks like when you incorporate land stewardship ideals within solar arrays. I'd like to point out that the Department of Energy has funded some larger scale grant programs, as well as the USDA, and different states like New York, Jersey, and here in Colorado are providing grant opportunities for folks to learn more or to practice agrivoltaics in their communities. Today, as I mentioned, we'll be talking about operations and maintenance in agrivoltaic systems. With us today, we have Terry Nelson with Namaste Solar, who's a journeyman electrician. We have Jesse Robertson Dubois, Blue Wave Energy's Director of Sustainable Solar Development. And we also have Sarah Roberts of Silicon Ranch, who's a solar generation asset manager based in Birmingham, Alabama. And Jesse, I forgot to mention where you all are. Jesse's in Massachusetts, and Terry is, just a bit north of me here in Colorado. We really appreciate you all taking the time to join us today to learn more about agrivoltaics, how solar companies handle operation maintenance issues within agrivoltaic systems. And without further ado, we are going to get started on our talks. So what I would like to do is to have our panelists come off mute, and we will go around and have each person be able to introduce themselves a little bit more, as well as with their what company they're with and what they're doing in agrivoltaics. So Sarah, if I can pass it off to you to start.
Good afternoon, everyone. My name is Sarah Roberts, and as Byron mentioned, I live in Birmingham, Alabama, and am employed at Silicon Ranch Corporation based in Nashville, Tennessee. I graduated with a bachelor's in marketing and industrial distribution. And that led me to work in sales for a chemical manufacturer immediately after graduation. And then I had a relatively short stint in property management before landing a role with an unregulated wholesale power company as a department coordinator, and moved into an engineering analyst role to help manage a portion of the wind fleet there. In May 2023, I moved over to Silicon Ranch, where I made the jump to solar asset management. And for those of you who haven't heard of Silicon Ranch, we are an IPP, or independent power producer. We were founded in 2011, and we have grown to include multiple businesses under Silicon Ranch. Now we have Clearloop, we have regenerative energy, and then we also have SREPC, or Silicon Ranch Engineering Procurement Construction. And we have a little over 3 gigawatt portfolio across 15 states, and our first project in Canada recently. And huge variety of not only C&I sites or commercial and industrial, but also utility scale projects. And that's where our largest focus is right now and will remain.
Thanks, Sarah. Jesse?
Yeah, Jesse Robertson. For Blue Wave, I'm sort of our in-house agricultural expert. My background is not in solar at all, but I'm a farmer and a land conservation geek. I had a policy stint working for American Farmland Trust doing farmland protection policy. But Blue Wave brought me on to help them design and build better systems for agrivoltaics. So Blue Wave is a distributed generation scale developer based in Massachusetts with a long history in Massachusetts in the Northeast, a couple hundred megawatts that we've developed over the years. But at this point, going back 2 years, we transitioned from being a dev and flip shop to being an IPP. We built our first fully agrivoltaic portfolio in 2023 for Massachusetts high clearance, widely spaced agrivoltaic projects, and one sheep grazing, relatively conventional array, but with sheep grazing. Another portfolio we built last year in Maine, and then more going in construction this year in Massachusetts and New York. And we're at this point in about 10 states at various stages of development, all in the distributed generation space. My own background, part of what brought me to Blue Wave was as a farmer getting involved in solar grazing and in agrivoltaics. So when we get around to sharing pictures, I'll show some some things that I've discovered not only in blue wave arrays, but in arrays that my family manages from the, well, not PV O&M, but site O&M in terms of solar grazing, as well as some great pictures from sites that I've snuck into over the years when I was first trying to understand the business and what I should be looking for as a farmer who wanted to get inside the fence. And I started crawling under some fences to try to figure out what was really behind the gates here. So happy to share some of those.
Thanks, Jesse. We won't talk more about you sneaking into private areas. That's fine, friend. Terry?
Hey everybody, I'm Terry Nelson with Namaste Solar. I'm a journeyman electrician. I've been in the solar industry for 7 years actually this month. So happy anniversary to myself. No, I'm just kidding. But yeah, I started my solar career on the builder new construction team, doing end-phase systems for new homes. Lennar specifically was the builder we worked with. And then kind of moved into a service role after that. I learned quickly, and service felt like a better fit for me. So I moved into a service role really fast. Was on residential service for a few years, and then came to the commercial service team in 2020, and have been here ever since. I think it's probably the best fit for me just because of my background. I grew up on a farm in Wyoming. So, you know, working with my hands, working with large, heavy equipment was kind of my forte. And O&M and commercial construction just kind of was a really good fit for me. But Namaste Solar is the oldest EPC in the state of Colorado. EPC basically means that we are building and operating C&I and utility scale and residential solar systems. But we also are the oldest O&M provider in the state, as well as being a B corporation, employee owned. So there's a lot of things that make Namaste Solar a great place to work, and I love my job every single day.
That is a happy man. Thanks, Terry. Appreciate that. So for our audience to understand how we're going to do this webinar today, we will go between each of our speakers sharing different stories about their time on solar arrays, dealing with O&M issues, mostly with agricultural activities going on, sometimes without, just so you have a better understanding of O&M issues that can crop up in agrivoltaic systems. For our participants to know, if you have questions, you can please put them in our Q&A chat at the bottom. You don't have an ability to chat with other participants or raising hands or calling out at all. We will just answer questions through the Q&A during talks, but more interesting questions we will take at the end after all of our stories have been collected, and we'll be able to answer any further questions that you all have. So to start off, we'll have about 5 minutes per speaker. I think our first round of talks is more on the negative side of negative impacts of agriculture potentially within solar arrays. So I will pass it off to Sarah to go ahead and start her talks, and then we'll go around.
All right. So the first thing that I'm going to talk about, it's called cattle tracker. We hear the term cattle in the solar world, and immediately there's a little bit of pause, right? Concern, hesitancy on the O&M side. SRC received a Department of Energy grant where there was an opportunity for funding and a research-backed approach to integrate regenerative cattle ranching into our solar energy farms, and hopefully scaling up further and further to be at our utility scale solar farms. It began in 2023 with the creation of an advisory committee and the research group. And that consists of agrivoltaic experts, regenerative ranchers, animal welfare scientists, soil scientists, a very multidisciplinary group of experts. And one of those focal points throughout this program is optimizing cattle co-location on utility scale sites. So what does this actually look like in the field? What are we actually doing? There is an outdoor test lab. It's 4.5 megawatts DC, and it is our project in Christiana, Tennessee. We're almost to commercial operation this year. And this is an SMA string inverter site with First Solar modules. There are 3 sections. So within the array itself, it is split between a cattle section, a conventional mow section, and then outside of the array, there's the 3rd section with cattle outside of the fence itself. So these 3 different sections really allow us and the research group to compare and assess overall ecosystem services, but also cost efficacy. So that's a little bit of background. Expected challenges and considerations in this. Material is obviously one of the things that first comes to mind. Obviously, our pylons have to be different. We have to have more robust guards and fencing, not only to protect our equipment and personal safety for our boots on the ground, but also we have a lot of NERC sites. NERC is, end all be all. They are the law. They have certain requirements. If you've heard of NERC CIP requirements, CIP, that is critical infrastructure protection. And that is a very low bar. So if we say have a fence knocked over by a cow, we would have to report that. But critical infrastructure is the most basic level. That's the things that NERC typically does not want to hear anything about or have anything reported on, because it is critical and the lowest level of security that we can have. In addition to material resource requirements, we have to think about people too. So to perform a maintenance task efficiently, but also keep safety at the forefront, tasks that were previously a 1 to 2 person job may require additional resources. For instance, with a broken module or a blown fuse on the back of the modules, those will require ladders or hopefully not scaffolding, but something, and it will require additional people to have that job completed. And then lastly, time resource requirements. We haven't even begun this process yet, but there will need to be a creation, compilation, training of new processes. There's going to be standard operating procedures, liability waivers, safety data sheets on cow poo. For our sheep sites, we have SDSs for sheep excrement. So there's going to be a lot of administrative processes as well that have to be set up. Overall outcome, again, this is ongoing. We are in the beginning stages of this, but we do already know that it's not impossible. And we're realizing and recognizing there's a lot more potential benefits than we initially thought. Some of the impacts that we anticipated, in addition to revitalizing the land and creating new pasture land, we want to expand the available lands to ranchers and solar plant operators. So we're asking better questions now, back to efficacy. For instance, do modules need to stay in tabletop position? Do we need trackers? These are all things that we have to consider with larger animals, particularly cattle. So overall, it has been worth it. We have a relationship network with government, research institutions, as well as our local communities. So that has been huge for us, a great benefit. And the big next step in Cattle Tracker for us will be kicking off construction in 2026 for another Tennessee project, and that will have 20 megawatt portion that will be used for a cattle tracker program.
Cool. Good to know. Thanks much, Sarah. Jesse, I'll pass it off to you.
Yeah, so let me I'm going to share a couple of pictures if I can. Sorry, one more second. I think that's you.
Pictures get away from you.
It did. Well, I'll just start chatting, I guess, because the Zoom screen is not giving me the button to make it say yes. So Blue Wave has been kind of just going for it. We have been building projects. We have not gotten to the stage of having SDS sheets for excrement of various kinds, but we do have cattle in arrays. And we did a test run of this, Byron, and I don't know why I can't get this thing to show it to you. Try
Something's
that.
coming up.
Okay, good. Sorry about that. So I'm just gonna share kind of a bunch of pictures, but this is a Blue Wave site that we built intended for cattle and for hay production, as well as some pictures from a bunch of other ones. But part of what we're looking at, and just a little background on me, this is from pictures from back when we got started solar grazing, and on the pluses and minuses. This is me falling down a hill behind a solar array, as well as my daughter, who is now largely taking over the solar grazing business while I'm working for Blue Wave full time. But we're really interested in trying to figure out, what are the heights, what are the spacings that can make things work well, and how do we make it work well for the farmers that we're working with? This is Tom and Michelle in this array. We're worried about the space for the equipment. We're worried about being able to both do crops as well as cattle. And to get the benefits of shade for livestock that are in the system, as well as when we can do that for crops as well. But it's really hard to permit all of those things. And we find a lot of challenges with towns doing fence line layouts, having the clearances we need, etc. And so we end up cobbing things together. So we have, like, here's an example from a site I found one time where they were, just had more topography than they were really ready to deal with. They have panel heights that are like 8 inches off the ground. This one isn't a Blue Wave site, where the construction ends up really not dealing with the outside the fence areas, leaving silt fence outside the fence. This is a site that I found while scouting for solar grazing sites, making it unmowable, and it builds up over time. Or rock swales underneath the panel edges, which makes it much more harder to maintain. Or forgetting about water and needing to, as an afterthought, add in a hand pump because you don't have a good way to get utilities, etc., into the system. Outside the fence areas that, you can bring sheep in there and you can deal with the outside the fence areas as long as you don't have too much coyote pressure. But inside, if you don't have good execution up front in constructing it, you can have real challenges with mowing or grazing the site. One of the things I love about this picture in the center is those are, clear backsheet bifacial panels which from a agrivoltaic perspective sounds great. But if you wreck the soils during construction, it doesn't do you that much good to get that extra light down into the ground. We are wrestling with, as an industry, you know, how over time do you keep these things together when things happen to fences, when the execution doesn't hold up? You know, this is bracing on posts that essentially these brace wires are held together with little 3/8 lag screws that are just going to pull out of posts over time. And these are things I found. Most of these pictures are from Massachusetts, but really across the industry, there's probably pictures from 10 different solar companies and probably that many different builders over the years that I found. Wiring. This is just an example I found walking through. This is actually one of the ones my family grazes, but that's what happens when a wire shorts for whatever reason, nearly, you know, burns its way through the structural members. That's why really clean wiring and that's really well executed is so important. And if you want to put livestock into that system, making sure that you don't have those kind of wire hazards is incredibly important. The picture on the right in here is a site I found that basically the whole site was held together with zip ties. And I think this was probably 8 or 9 years after construction, and it wasn't held together with zip ties anymore. On the one on the left is some really nice wire management I found in another one. The ground cabling and the picture in the center, I thought that was it, that you can't see the ground rod, but it's actually out from the anchor post in the zone that was getting mowed, and the mower had just whacked it off the ground rod over the years. You know, a lot of those kind of just little things I've run into. How can you do it a little better? This is a Blue Wave site where we've got combiner boxes and these weatherhead drops coming down. We protected the weatherheads with additional pipes, but then we used, you know, just sort of farm hacked it with polywire, little guards around those weatherhead drops to make sure that we wouldn't have cattle rubbing on the more vulnerable pieces. And then in another area where we had the power to the motors on the right-hand picture, you can see we were able to get it tucked right in up against the post. And 2 seasons of grazing so far, and it's working out okay. So sort of different approaches. If you can't get the execution perfect, you know, the picture on the left, you can see we've got stuff that cattle rubbing on it could be problematic, but there may be a farm way to fix it as well as a solar engineering construction way to fix it. Those are the big ones. That was the end of my slideshow, but just real quick, some of the pictures of the kinds of things we're dealing with.
Thanks, Jesse. Terry?
Yeah, thanks for having me. So as an O&M technician, I spend most of my days in the field dealing with the issues that kind of Jesse had mentioned. Not all of them, but those are definitely things that we deal with. Animals rubbing on things, animals nesting in things. So, you know, preparing your site in advance is definitely huge. And getting somebody who has experience, you know, doing that and can kind of guide you through that is the big piece. But you know, what I'm going to be talking about is maintaining and operating these solar fields. One thing that was mentioned 20 years ago is that solar doesn't have a lot of working parts, and so it doesn't need a lot of maintenance. Well, that's not true, especially with trackers, but just electrical equipment in general. When you're pushing current through electrical equipment, it creates heat, and too much heat can cause boom, boom. So here's an example of a breaker that had a catastrophic failure. And what happened is that's the bussing on the back of the breaker where it attaches to the switch gear. Might be a little bit over your guys' head, but this is like an 800 amp breaker. So there's a lot of current rolling, and the connection was fine, but the equipment wasn't able to dissipate the heat enough. They had not vented it properly, and so it was just building heat, and all that heat was stacking up, started melting metal. And you guys can see my photo, right?
Yeah.
Okay, cool. And so a little bit more. as we're talking about, trackers do track, and with trackers tracking, things break, right? And some of the manufacturers did not use bolts or hardware that was strong enough for this thing to track all day, every day long. And I don't know if this is a Silicon Ranch site, but I know that they have some problems like this that I've seen. But I think this is in the San Luis Valley, which is in southern Colorado, and it gets pretty windy down there. And this site is pretty heavy. These are called First Solar thin film mods, and they're stacked 4 high, and they're very heavy because they have glass on both sides. And so there's a lot of weight that this thing has to hold every day and hold it from the wind. And it didn't do that. It failed catastrophically. So there's just an idea of some of the failure that we see. Here's another one. Hold on a second. Of some catastrophic failures with arrays. This is another one where it just couldn't handle the weight and it broke everything. So as an O&M provider, right, this is, jobs security for me. Oh, and as a asset manager, this is money out of your pocket, right? And we want to make sure that we're installing equipment that's going to make it so you don't have to put tons of more money into it. You want to buy equipment that's been through these thresholds and has been proven, right? And so providing and getting a good EPC contractor to help guide you through this process is also huge, because we've all been here, we've seen failures, and we know what's going to work and what's not going to work. Okay, a little bit more, just some more fun. We talked about animals nesting. Here's my fave from Jack's Solar Garden. Byron, we went out there to do a PM, which is short for preventative maintenance. What that means is we go to site either annually or semi-annually and look through every component of the array, test all the strings, test all the wiring, everything gets tested. And when opening up boxes, we found that there's a lot of voles that are living in Byron's garden because he's got a lot of stuff to eat out there. And they found a way into the boxes and decided to make a house out of that is wool from a sheep, I do believe, which is probably pretty warm. I would say that that's a nice house, but he got evicted. And let's see if I got anything else. Some more heat damage. I think the biggest thing is heat is a reoccurring issue in solar farms, especially these larger utility scale sites where, we're running 2 or 3 to 5 to 10 megawatts. These sites have a lot of power running through them. So, maintaining an with a thermal imaging camera to be able to see these heat problems is crucial. It looks like my internet is unstable, so that's all I got. But one thing that I do want to leave you guys with is wire management, like Jesse said, is huge. I have seen animals jumping up on wiring. Sheep, as an example, sheep do a lot of playfulness. I don't know if we can call it playfulness, but they were jumping up on each other, pulling wires out, undoing strings. That is a hazard for them, right? Because they could get shocked or electrocuted. But also on some of these trackers, they're pushing e-stop buttons and stopping the tracker from tracking. So then we get a phone call that says, hey, tracking properly. And then we have to go out there and push that e-stop button. So, making sure that we have someone going through these sites and saying, hey, these are areas that should be fenced off. These are areas where sheep shouldn't be allowed, because there is potential for animals to get hurt or for loss of production, right? The idea of these sites is to produce, generate revenue, and we want to make sure that we don't have anything that's going to stop us from generating revenue. So get yourself
Thanks,
a really
Dave.
good O&M provider.
I always appreciate you showing that picture of the mice in my inverter box there. That's a good one. So just to recap some of the challenges that our speakers just went through, from thinking through excrement removal within solar arrays to the need for sturdier materials and those that can dissipate heat, just thinking about solar installations in general, and then you add on top either cattle or sheep or other animals into that system. The need for planning construction practices so that you don't destroy the land, so that it's still functional thereafter for any animals or agricultural activity going on. The importance of wire management. Both Terry and Jesse really hit on that, and I really appreciate that. Having wires high, tucked up, high and tight, flush up against things in sturdier conduit. To me, that's really important for the safety of people, animals, and the solar array infrastructure. And to Terry's point of mice around hanging out in solar arrays, or the bird nests that one might find here at Jack Solar Garden, is by having agricultural products and activities going on, it can attract pests that may also have some negative effects on the solar array. So just recapping some of the challenges related to the O&M side of things. We'll continue down our story path, and I'll pass it back to Sarah. I believe we're going into more of the opportunities, the better side of having agriculture within solar arrays from the O&M perspective.
Yeah, thank you, Byron. Jesse and Terry actually kind of set me up. They talked about a couple of things that I'm going to put a little bit of a positive spin on. Let me go ahead and share my screen because I did forget to the last time I was talking. Nothing earth-shattering, but still nice to have something to look at. Okay. Can everybody see my screen?
Yes.
Okay. Am I in presenter mode? Okay. So, something unique about Silicon Ranch is we have third-party grazing providers, and then we also have our own in-house flock with our own ranchers. They are employed by Silicon Ranch. And so what triggered us to even have this mixture of in-house and third-party? Our regenerative energy group recognized that using only third-party grazing vendors, as we were in the beginning stages, it would limit the number of sites overall that we would be able to use regenerative ranching methods on, especially since the largest sites and the most saturated area of where we have sites are in very rural areas, like Southeast Georgia, well, really all of South Georgia, parts of Tennessee. So our current setup now, we have 29 grazed sites. So of those 29 sites, 7 are with our in-house sheep flock, and then 22 are third-party grazers. Of our third-party grazing vendors, we have a total of 7, and they're across 5 different states. But with the combination of in-house and third-party grazing, we have around 20,000 acres total that are being grazed, and we're basically able to get to that point because of that combination. They're both about half and half or equal acreage. One of the challenges in this is certainly the close coordination that is required, not only between the internal groups. For instance, I work for SREPC and asset management. Our regenerative energy is a separate business still under Silicon Ranch, but we have to work in close coordination constantly. And then, as we all know, the more individuals that are involved, we have self-perform O&M fleet, We also have third-party O&M. So it can get not heated necessarily, but there can be a little bit of tension in the air sometimes at some of these sites. So we have to do our best to manage that as the owner. And you went into strict wire management. I think both of you did. That's just one example of an alignment of the standards that we have to set across all of our vendors, whether it's self-party or self-perform or third party. We have to have strict wire management for our DC cables and harnesses on the back of our modules. And then with our grazing vendors, both our third party and our self-perform vendors, we're still figuring out the best way to do things because we're just now getting to a point where we are considering these challenges up front and in the design stages. Whereas a lot of our sites, they were designed with land management in mind, but not necessarily having animals on site as well. When we were doing fencing and protection around the string inverters and central inverters, for instance. I'm sure Terry sees it a lot, as well as Jesse. If there is not fencing around inverters, the sheep are just drawn to them. They have shade, and they just want to be there next to the inverters. So one thing that a couple things we've implemented at our central inverter sites, we make sure that hot grips are available if we don't have the nice sheep panels like in this picture. But just allowing and making sure that the expectation is we keep that ease of access for our O&M technicians to get in and get out. We don't want to slow the other party down, whether it be our ranchers or the O&M providers. So again, close coordination and communication. And then also another thing that I always have to think about is NERC compliance. We have to consider access restrictions and additional protocols if we have workers or vendors that need to work outside of normal working hours, which is often the case at our sites. And then just to close out, overall, I included this article from the Appalachian Voice, and it's on our website for Silicon Ranch, but this is about one of our grazing vendors. His name is Cody Moore. And the picture is from our site, Turkey Creek in Lancaster, Kentucky. But overall, this mixture of in-house and third party has allowed us to have a great ability to gain exposure and different ways of doing things and different strategies. And then with our in-house flock, we have a great ability to shift our existing way of doing things, but we're also empowering, again, the local communities and giving a voice to the local farmers out there. And hopefully in the next 3 to 5 years, we'll have expanded our in-house fleet to Alabama, Mississippi, Tennessee, and Kentucky. But we're also planning to expand growth with our third-party vendors as well.
All right, thanks, Sarah. Jesse, pass it back to you. There's always one person with the tech issues, eh?
Yeah, I'm winning today. I apologize. I thought I was with it. All right. So get that out of your way. Good stuff. With sheep and with cattle as well, you can extend the grazing season. In the Northeast, we see good grass growth right into the fall and starting earlier in the spring, which is great. We see in the summer, really good grass growth, even in the middle of summer. This is a period where you can see, just really very little difference between what's under the panels and what's outside in the first part of the row. That picture on the left. But if you look at the far left of that, there's you can see the grass. If you can see my cursor, the grass over at the in the sun is actually gone dormant. It's gone senescent. It's headed out, and that means the forage quality is going way down in that area out there. Whereas here, underneath the panels, you still have really good quality grass, and we see that pretty commonly on solar sites. This one on the right is a site that is a really wet site. Those are cattails in there. And before the site was getting grazed, O&M was having a real hard time mowing it because they would just rut it up. They would get equipment stuck. It was a real challenge, right? And sheep are able to just do a better job in here. We have to watch, health issues related to feet, but they can do something that other O&M methods can't. This is an example of you can do really clean management where you are managing the site well, you can get stuff clean using just sheep. It doesn't need to be mowing. It doesn't need to be a trade-off in terms of O&M. You can do really good stuff out there. And you don't get these guys without having more biodiversity in the array. And that's pretty hard to maintain with a mowing only scenario because a lot of the um, insects that are the base of sort of the food chain for the other critters end up overwintering, at least in the humid parts of the country, in the hollow stems of all those plants that you need to mow down if you're going to maintain the site. So having that overwintering habitat stay from year to year gives you this opportunity to have so much more diversity in there. And then, I shared the picture way up at the front of the farmers involved, but the farmers are so key to the messaging to the communities, both upfront when we're going into permitting and then on a long-term basis. I don't have a good picture of it, which I was embarrassed by, but we also find it's really helpful on an O&M side to be able to ask a farmer, hey, can you go look at they're not electricians. They're not going to get into doing any serious PV O&M, but there can be times where if the site's down for communication, and it can be helpful to have somebody who's right nearby who can just take a picture of the screen on an inverter, send it back and say, this is what's going on, right? And that tells us what level of problem do we have? Do we want to roll a truck immediately? Do we want to roll a truck next week? Is it just a glitch in the communications that may come back on its own? And every time you don't roll a truck, that is a huge savings. We also see it in terms of, we have trees where a lot of our solar sites are. Tree comes down on the fence, conventional O&M, that could sit for a long time. You could have deer in the array. Farmer's going to tend to find it right off the bat and be well equipped to manage it, to deal with the problem. Take the chainsaw out there, clean it up, maybe even get the fence fixed up faster and cheaper than we might be able to have somebody else do it. So there's a lot of synergy and overlap there.
Thanks, Jesse. Terry?
Yeah, so ditto on what they said. No, I mean O&M is quite the beast in some days, and other days it's not. And really it just comes down to the quality of the build, right? And doing things right from the beginning is a lot harder, a lot easier than trying to fix something that was done wrong in the first place. So, I just want to reiterate that, choosing your EPC who's going to build this site is very important. I know money is always an issue, but you know, sometimes you get what you pay for. So, you know, just keep that in mind.
I'll take that recap. Thanks. Then I'll give the speakers one more opportunity to share any last stories, any last thoughts before we pass it off to our our attendees to share any of their questions, or that we would answer their questions. So if you have any questions from anything that our speakers have gone through so far, please go ahead and start populating the Q&A. And once we're finished with this last round of stories and conversation around O&M, we'll get to your questions. So, Sarah, I'll pass it back to you if you have any additional thoughts that you'd like to share with the group.
Yeah, just real quick, I will say from my position in operations and maintenance and asset management, even though I do work in very close contact and coordination with our regenerative energy team members who manage these grazing and mowing vendors and just overall land management for our projects, I'm going on 2 years of being at Silicon Ranch, and I'm still surprised at the possibilities and opportunities. It almost seems like they're never ending with agrivoltaics specifically, and there's just so much more coming out, but it's far beyond just cattle and sheep. We have a gopher tortoise habitat at one of our sites. You know, having bee pollinator habitats or native plants, you know, a section designated to native plants. There's so much that you can do in this space and with the land that we hadn't considered or hadn't really put a lot into previously. So overall, I appreciate you putting this together to just raise awareness, and it's just an opportunity to learn, but I'll just leave it at that.
Thanks, Sarah. Jesse?
I think it's the diversity, of what's possible, right? I mean, Sarah's working mostly at the utility scale. I'm working at the distributed generation scale. There are really different issues at different scales. There are really different issues in different parts of the country, but the amount of creativity there is out there to figure out what's going on is phenomenal. At the distributed generation scale, I keep telling my solar colleagues, we're working with fields, not farms. The utility scale farm scale, you can actually kind of have whole farms inside a solar array. And that difference lets you, we're going to start to iterate so many different solutions as we scale this out at multiple different places, find different approaches to things. Come up with different farm hacks. I have another picture of just like how I run sheep fencing underneath panels that are too short, right? Like sometimes you just can't get in there with the normal stuff, and you do little things like you grab a hank of grass and you twist it up and you tie a knot in the sheep fence, and now it fits, right? And you get underneath that panel without shorting it out. There are so many little things that either are soft solutions or simple hardware solutions that the whole industry, the farm side, as well as the solar side, as well as the conservation, biology side, have all got to just start playing with. And it's the playing with that is really scary from a solar perspective, but also is where we're going to start to innovate and develop all kinds of cool new ways of doing things.
I appreciate you mentioning that about getting the electric fencing underneath the solar panels. I've had to just take baling twine and tie together a few of the different strands much closer to help pull it down so it kind of bows just underneath where the solar panel will, the lowest edge of the panel.
Yep.
Terry, last thoughts, recaps you want to do for us?
I mean, I got nothing. I think they're doing pretty good at covering all the bases. These guys know their O&M. I just work here. No, but I kind of got distracted. What was the question again? Just real quick.
Just any last stories that you'd like to share about O&M within solar array systems? Any last thoughts?
Hmm.
And we'll
I mean, I
pass it
think
off to questions.
I think I've covered most of my bases. You know, it just, you know, I do think that having animals on solar fields is a good thing. Like keeping the quality of the ground, right? And the sheep and the cows are going to do that. I have noticed that, you know, they tend to stray towards certain types of grasses, but for the most part, they are doing a great job of maintaining the site and keeping it from being mowed. And so there's a lot of benefits for that. And then on top of that, right, you know, all of the sheep's feces, all of that is helping keep that ground good. And coming from a farming background, I think having the animals on the ground, you know, during this 20-year lifetime of this is going to help that ground become successful in the future and not become worthless ground. So
I appreciate that. Well, we'll take a look at the Q&A that we have here. I'll note for our attendees, there's a handful of questions in here around the economics of building a solar array. We probably won't touch on those since we're more focused on the O&M side. But I do like this one question on how do you manage cattle on a large scale solar project? I think it sounded like both Jesse and Sarah have had some thoughts on cattle at a larger scale, or even just within a solar array to begin with. So I'll pass it to either of you that want to start talking about managing cattle.
I think, you know, cattle, it's about protecting the equipment. They're big, they're strong, they like to rub on stuff, and sometimes they just do dumb stuff without meaning to. Um, but that's kind of obvious. I think the thing that's harder is for the industry as a whole is understanding how to fit cattle operations into the scale of solar arrays and vice versa. With sheep, it's a little easier to scale up and scale down and move sheep from site to site. With cattle, it's more expensive to do the trucking and to have good vegetational control. You know, you're not worried about grass heights if you have a system that can accommodate cattle, but you're worried about the vines and you're worried about the trees, and you need to make sure that your grass management is going to nip those things in the bud, if you'll pardon the pun, before they get away from you, or you're looking at vegetation management as a result. And so it's that rotational grazing infrastructure to move cattle through the site, to have a site that's big enough to have a viable herd size to be useful to the people doing the work. Those are some of the things that I think are going to be the most interesting for at distributed generation scale. You know, with the Burgundy Brook farm site, we dropped a 2 megawatt, 15-acre array into an existing farm, and it's just 2 extra fence pastures that they have in their rotational grazing system. They're there for a pretty small portion of the year. They're on all of the other pastures of the farm for the rest of the year. But you start scaling that up, or you start trying to move cattle to places where there isn't the rest of the farm right there, and you can't walk them into the solar array, and it gets a whole lot more challenging.
Yeah, I think you covered it. That's everything I would have said. And again, with our cattle tracker program that we're a part of, we are very much in the beginning stages of that. And so we are looking on how to best scale. But just overall, the purpose of us starting at that smaller 4.5 megawatt site is going back to exactly what Jesse said. Right now we have control sections, and that's more so we can very distinctly identify, you know, what trade-offs are there, what risk are there, what issues are we having in every section. But, you know, come 2026, and we have a larger, again, it's only 20 megawatts, but it is, you know, obviously a lot larger than what we have now with cattle. We are going to have to assess and, you know, figure out the best way to do a rotational program. And again, keeping the equipment safe, but also the people there too.
Like another question here about how do neighbors react? Since you all have been out at solar array sites, maybe you have people that drive up while you're out there and wonder about why are there animals within a solar array. So be it the general public or neighbors, do you all have any stories or interactions, anecdotes that you could share about the general public being interested in what's going on within a solar array?
I'll say real quickly, generally the public is, from what I've seen and what I'm aware of, generally the public is excited when they see sheep and cattle, and oh, they're just so cute, and look at the babies, and it's an exciting thing, and I think it also it speaks to the fact that we're trying to do things the best way that we can, and trying to manage the land that we have as responsibly as we can, not only for us, but also for the animals as well and our stakeholders. But in general, I don't think I've ever heard a complaint where we have animals at our sites. The complaints are when we don't have those cute furry animals. Jesse, curious to see what you have on your side.
Yeah, so I've seen basically four responses, depending on who it is. different types of people, but I think they fall into four categories. One are the folks who just think it's awesome. They love it. They're bringing their kids out, like they're stopping there. Their kids are like pressed to the fence, looking at the babies. That's great. Another one, sometimes at the exact same solar site that I've seen, is what you're talking about. I've never seen sheep in there. Yeah, they're there 3 times a year, every year, but they're only there for a short duration grazing period. And if you're not looking out your window, I can't fix that, right? Like, I don't know. But there are a surprising amount of people who just aren't even looking at it, right? And that, to me, that also tells me that, well, then the solar array as a whole isn't something they're looking at or noticing. And maybe it's not nearly the problem that everybody says it is, right? The third one is the people who are convinced they hate everything about it and don't care whether you're farming in there. They just hate it because they're convinced they hate it. And I've seen a lot of people that we can't change that. It's just an optics and aesthetics question. And for some people, ag completely changes that. For other people, doesn't touch it at all. But at least it makes everybody get honest about it, right? If we get really honest about this is just an aesthetic issue. Okay, cool. It's an aesthetic issue. We're clear. And then the fourth one is the rarest, but it's the one I hate the most, which is the keep your damn critters on your side of the fence, which is when you have a bad fence and the sheep get out into a neighboring farm. That's like the worst scenario, right? Like, I feel bad about it if it's the neighbor's backyard, but the neighbors usually think it's kind of funny. When you rile up the neighbor's dairy's cows, nobody's happy. So again, goes back to fence construction.
I like one of the recent questions that popped up here. Terry, I might pass this one to you to start. As a solar company getting started in agrivoltaics, what team members do you recommend getting on your O&M staff?
Okay, so you're looking to start up an O&M company. So I would recommend possibly an electrician. Not every state it requires one, but I mean, I would, and technically you're not required. You need to have someone qualified, but I would find somebody who understands electrical theory. And I mean, that's the biggest thing is yeah, mowing the grass is great and things along those lines, but there's so much electrical needs for the site that I would definitely suggest, if you're starting an O&M company, to hire an electrician and hire somebody who has experience in solar.
Good answer. Anybody else?
I'd say I guess it's context, right? If you're talking about the O&M company on the asset management side, it's sort of a different group than the folks doing the on the ground work. But in both cases, I do think there's sort of no replacement for people who have experience managing sites of one kind or another, right? Yes, there's the electrical piece. I think it's great to have an O&M person there, but farmers are great at just understanding how water moves, how vegetation grows, what the soils are doing. from a site management perspective, that's really critical. There are really experienced landscapers with some biological science conservation background that can do similar things. But you're not going to do good biological management of a site without that kind of holistic soils, vegetation, climate interaction as part of the understanding of what's going on that site. So it's incredibly helpful if you can source that and include it as well. Could be consultants, doesn't have to be on the team, but it's incredibly important to have the capacity.
Have someone that is designing utility scale systems here interested in cabling, that they have a client looking at getting wires above at least 24 inches above grade for sheep grazing. They're curious if there are standards and potentially recommendations for wires, and sounded like everybody had an opinion on wire management. So let's talk more on wires. Who wants to start?
And I'll throw out there that the standard sheep net that's used in the industry is 30 inches tall. So if you're looking for like the best case scenario, you want to be able to get that 30-inch net across the site underneath the cab lines or the drive lines. That's a really tall cab or drive line. It's not going to be every site that you're going to be able to do that. Once you're below that, there are a bunch of different strategies, but there's tens of thousands, maybe hundreds of thousands of acres being grazed with sheep with lower cabling and drive lines. So it's not the end of the world. But we defer to Sarah because she's probably seen more of it.
Well, I was just going to say pretty much the same thing. There are possibly hundreds of ways of doing wire management. And it seems like it depends on which site you go to or which O&M manager you're talking to as far as, what's the best. It can be a little subjective, I think. And then also, I think one thing like Jesse was showing pictures of, sometimes there's zip ties used. Sometimes there's something called a sun bundler. That's like a little metal clasp or wire thing that's coated in plastic. We just had some work done and there's a new First Solar clip that I've never seen before. So there's constantly new things on the market and different materials. But it truly depends on who you're talking to as far as what is the best. Yeah. Terry, I'm sure you have something to add though.
I would totally agree. We're moving away from zip ties as a best practice in our company, and Sun Bundler is the go-to. It's 10 times more expensive than a zip tie, but it won't fail. But I've seen zip ties that are 20 years old that are still holding as well. So, there's cases to both sides, but I would say if we're doing a tracker system versus an array that's just southern mounted and it's not tracking, then definitely do something more than a zip tie. But I would agree, Sarah, that every provider is going to have a different aspect of what they feel wire management is and why it's the best. I don't know if there is a right answer for that. I think the biggest thing is, making sure that we understand what the problem might be and trying to figure out a solution to fix that problem before it happens. That's O&M's every day is, how can I prevent this from happening? And this happened. And so, now we have a good solution to do that, and we do that moving forward. But also, how do we foresee problems before they happen? It's really hard, but.
Agreed. And a lot of it too is just what kind of upfront cost do you want to put into it? Again, zip ties are obviously going to be a heck of a lot cheaper than a sun bundler or any other type of clip. So it's very situational.
Yeah, the phrase that we use is neat, high, and tight, right? What you're really looking for, and that's sort of like in order of priority. I'd say, height is great, but if you're talking about tight bundles, I'm really not that worried about them with sheep, right? A bundle of cable is pretty robust as long as it's going to stay together. It's when you have the single wires sticking out by themselves, those are the ones that sheep are going to get snagged on. If you have a big gap between a carrier wire and a bundle, that's a gap that sheep can get the neck stuck into, and the equipment's probably going to be fine, but the sheep could be in trouble, right? So it's that tightness that I think is one of the most important factors. How you achieve it, there's a lot of different ways to get there.
And I don't think the issue is as much now with building new sites, because we're most
Yeah.
EPCs have got it dialed in that they're, high and tight and better wire management, and the wires coming out from underneath the array, right? When they used to do it, they would just stub a pipe out of the ground and not even put a weatherhead on it and stuff it with some duct seal, and it was 10 feet from the array with these huge loops. And so it's like we've learned a lot in our years of doing this. It's just the hardest part is when you get to some of these older sites and having to manage them, that it wasn't built for sheep or cattle or anything other than to be a solar site.
I've seen in a handful of sites I'm a little jealous on, where they have the I-beam, and then they've done the electrical run from up underneath the panels to ground, like inside that flange, which that is as in my perspective, that's top notch, because there's no horn, hoof, head, hoe implement, anything that is going to get in between that steel I-beam and conduit to be able to rip it out or damage it in any way.
Yeah. And to be clear, we're talking a lot here about grazing, but for all forms of cropping, and for that matter, for mowing, right? Getting the cabling underground is the solution, right? You are not going to be haying an array or doing veg production in array if you can't go through from one end of a row to the other. If you have to turn around in the middle, you're limited to something like a zero turn mower or livestock.
Yeah, getting rid of those. What is it? We have single axis trackers that go north south, so the panels turn east west, and then when you have that cab that goes east west, that creates more of a grid within the solar array that you can't move those vehicles through, makes it a hell of a lot more challenging.
Yeah.
Are you referring to ATI?
ATI has a drive line, but the
any
cab,
drive line like that.
whether it's a drive line or whether it's cabling, anything that's running perpendicular to the rows, across the rows, then now you can't drive through, and it becomes a problem. If you have enough height, you can solve it. We've solved it with Blue Wave, solved it with our first portfolio in Massachusetts, where because of procurement issues in 2022, which everybody in the industry knows were terrible, we ended up using an ATI system, and it's a great system, but it does have that drive line. And so we've got sort of a hard stop at 8 feet. And for the folks who were doing cropping, we had to, work around like, okay, well, the cab tractor is not going to work. Do we have an open station tractor that can go through instead? For one of the vegetable arrays, we spec'd a imported Italian tractor that just barely has clearance to sneak underneath that sucker. But that's a Massachusetts project that's 10 feet off the ground to begin with. So having a drive line at 8 feet is a challenge, but not as much as it would be if it was at 2 feet or 3 feet or 4 feet.
I'll switch tracks here a little bit. There was a question around students performing or assisting with O&M, thinking about education within solar arrays and training. Every so often we get questions about engineering students that could come and help out with Terry out on our field here at Jack Solar Garden. And typically my answer is no, because I need them to be licensed electricians. So I will pass it off to you all as to thoughts on how or if students could be of any assistance on O&M on operational sites.
I was going to answer that online, but I thought it'd be easier just to answer it in person. So we work with Denver Public Schools to do stuff like that, not on O&M sites, but on like residential sites. And there is a lot of benefit in that, getting exposure to students into what solar is, and, trying to help them create careers, because obviously it is a high demand industry today. But I don't think in the aspect of O&M doing a like a preventative maintenance visit would be good for a student, just because there's so many aspects. Even bringing on a green apprentice is really hard because there's just so much to look at on some of these sites that are 2, 5, 10 megawatts that you really need someone who is as a good attention to detail and an understanding of what they're looking at. Uh, or they're going to miss things, right? And there's so much to look at, and through my years I've been able to, fine tune this ability to see things without really even looking. And so I think it's a skill set that has to be learned and tuned versus, having students come out to do it, which I don't think there's a problem with education, right? Have a student come out and educate them, but to do the actual work, I don't think that that's a good solution.
Yeah, if you're teaching well, that's what you're doing. If you're doing O&M well, that's what you're doing. Uh, there are what's coming to mind is a couple of examples where I've seen panels that weren't properly bolted down or screwed down, right? And it just doesn't get seen for maybe years, right? 5, 7 years after an array has been built. And it's like, why am I seeing light through that hole? There's supposed to be a bolt in it. You know? Somebody needs to do it. It's not that the bolt fell out, right? It's that it just got missed, and it's been missed on annual checks for years. If you're trying to pay attention to teaching somebody else, it's challenging to do that work well.
Can appreciate those answers. Jesse, we'll start with you on this one. Since you mentioned pollinators and insects, how do you manage grazing within pollinator habitats? Is that even possible, or what would you, any thoughts, experiences there?
So yeah, I'm very opinionated and passionate on this subject. I would say, how do you manage pollinator habitats without grazers, right? There, naturally speaking, there are no examples of meadow habitats that don't have grazers as part of that ecosystem. And when you take the grazers out of that ecosystem, what are you doing in place of it to manage that vegetation? If you're talking about a solar site where you're constrained by particular height, if it's a relatively conventional solar site, you really don't want the vegetation of any kind getting over, say, 2 feet. It's very challenging to do that in a way that preserves the value of that vegetation habitat. Yes, you can have pollinator during certain seasons, but where do those pollinators go when they're not there? If you're on a big solar site, where are they going to overwinter? Where are they going to spend the rest of their life cycle? Are they overwintering in hollow stems? Are they overwintering in the ground? Where are they moving for forage at different times of the year? What are they feeding on? What things are feeding on them? That whole ecosystem depends on some biological activity that it's very hard to replace with a mower, because a mower mows everything to all the same height, and a grazer moving through the system takes out a lot of the stuff, but not everything, and not to all the same height. And you have a much more diverse environment that's left behind that supports a lot more biology. Plus you have the manure in the urine cranking up the ecosystem.
Let's see. Well, here's one on ecosystem. If anybody else has seen this, maybe while you're just out on sites, Terry, or the other sites that you visited too, Sarah, what types of vegetation have you seen working within solar arrays? And I mean, you can broaden it out to agrivoltaic systems, but maybe you've seen either a certain type of weed or a certain type of grass or anything else that seems to thrive within solar arrays.
Yeah, we have a site we built in Watkins, and we planted wildflowers there. And they are not supposed to grow more than, I think, 2 feet and maybe 3 feet. And so they're not supposed to grow more higher than the array. But yeah, they're bringing in tons of pollinators. It's all these natural flowers and things along those lines, and it's working really well. And it keeps a lot of the weeds down as well, because they grow first, and stop the weeds from growing. And then obviously they come back the next year, right? They're perennials. Is that right? Perennials? Yeah.
Perennials.
Yes, those things. Correct.
Yeah. And I should say, I have a very Northeasterners bias. Even when I say it's very hard to manage pollinator habitat, because we have trees and we have enough rain that we have, you have trees being the problem in very short order. That's really what you're mowing for, trees and vines.
Yeah, we don't have that big of a problem out here with that.
Yeah.
mostly just weeds, tumbleweeds
Yeah.
that grow larger than the wildflowers.
OSHA. Yeah.
And then, it also sounds completely different from both Terry and Jesse. Again, a lot of my sites are in South Georgia, where I think it's clay, but it's very difficult for anything to grow there. It washes tremendously easily. We have a lot of crabgrass, bahia weed, things like that. But we also have worked with a lot of local suppliers in the industry, and we have some seed mixes that we've worked to kind of refine for these areas, but it's still challenging once it's been disturbed at all. So the goal is, let's get the project a year before we start construction. Let's manage the land so we can mitigate some of those effects, but those effects are still there. We can't stop it entirely, but it certainly helps.
Let's see, last question I see as being of pertinence here is around hay operations. I think, Jesse, you mentioned haying within a solar array. Any further insights you'd like to share about navigating that?
Yeah, it's really, when you get into agronomic crops, whether you're talking hay or whether you're talking row crops, I think the biggest challenge is starting that early enough in the process. It's a site selection problem, and it's making sure that you aren't constraining your site in terms of an assumed typical row spacing, because those are the types of things where having increased row spacing becomes incredibly important. And if you're not thinking about that early enough in the site selection process, you could end up with a site that you can't make it pencil and include those uses because you just don't have the width for that extra space. You're going to have a cost in extra cabling, and particularly because you should be burying it. So you're going to have an extra cost there. You can plan for that and you may find that you can absorb it. But if you just don't have the room on the site to hit your planned capacity for what you need to interconnect to make the project work, you can't fix that. If your lease or your site was settled 2 years ago, now you're trying to figure out how to fix it as a design problem later on. It's all about the row width. I'm far more concerned about row width and mechanical efficiency for the agricultural operation than I am worried about the impacts of shading. Um, Unless you're talking about a really incredibly tall system like the types of things you see in Europe, we're typically in the US not able to build those. We have a different electricity market. We have different solar incentives. We are not building the 15-foot tall European systems that you could maybe drive crossways across them. I don't see that changing anytime in the near future. We're talking about doing agricultural activity in the rows. Well, you can't drive through the steel posts. And so, it's all about the width. I'm not worried about the shade underneath because you can't drive there anyway. And agriculture is mechanized.
Yep. Just making note of some of the other questions in the Q&A. There's a handful around grants at the federal level these days. Who knows what's going to happen there? I'd say unlikely to, yeah, inconsistent likely. At the state level here in Colorado, the Colorado Department of Agriculture does have a grant opportunity open at this moment. I think grant proposals are due early May for agrivoltaic projects. It's not really around building an entire site because they have $300,000 to parse between a handful of people. So it's more around actually implementing or researching or providing outreach related to agrivoltaics. So there's a opportunity here in Colorado for a little bit of grant money. I don't know. Do you all know of any other opportunities for grant funds, maybe at a state level? All right, there we are. So
Massachusetts and New Jersey have incentive programs for agrivoltaics. Massachusetts is great. New Jersey, it's coming along. New York has just released a pilot to the first round of pilot. Hopefully that will continue, but those types of predictable incentives rather than grant programs, I think are really what's going to drive the industry to try the things that are more expensive or more challenging, because it's very hard to build a project on the hope of a grant in the future. It's incredibly challenging.
Fully agreed on that one. Well, Sarah, Terry, Jesse, thank you very much for taking your time today and share your insights with our audience. For your records, I think we had close to 47 people online at one time. So to all the attendees, thanks for spending the last hour-ish with us, learning more about operation and maintenance and agrivoltaic systems. And hopefully we get to see everybody out here at Jack Solar Garden at some point this summer. You all take care.
Thanks all.